For most professionals in the building envelope industry, there's a misconception of the amount of energy, or what's referred to as point bridging through fasteners, and the negative effect that it has on insulation and wall assemblies. So what we've done here, just to show the significance of fastener point bridging, is we have here drywall. And I've got a fastener that sticks through here about 1/2 inch. And what we're going to do is we're going to freeze this fastener into this water. So you can see the pan is full of water. So I'm going to put it on top of here, as you can see here. Then I'm going to take this sample, which is identical in every way. The only difference is the fastener is longer. That goes through 2 inches of Quik-Therm insulation. And again, the fastener head is going to get frozen into the water. So we're going to put it on top of here. Everything is set properly. Now we're going to freeze it. Once the freezing is completed, we're going to put temperature probes on these fasteners, and we're going to determine which fastener, if any, is colder than the other fastener. So we've taken our frozen samples out of the freezer. They've been in the freezer for about 24 hours now, and as you can see, the heads of the fasteners are frozen right into the pan. So what's going to happen here is the thermal bridging, or the cold, is going to continue to move through the fastener. It's actually more the heat going to it than the cold. And what we're going to do is we're going to check out the deck temperatures, or the drywall temperature, on each of the samples. So we're going to put a thermometer probe down here, and we're going to tape it to the drywall. Going to take another one on the Quik-Therm side here that's insulated, and we're going to tape it down. And then to somewhat simulate what's going on into a cavity of a wall, we're going to put some bad insulation. Now this is not cavity bad insulation, but it's a fiber insulation, mineral wool. And we're going to put it down over the center, and you can see the fastener tip is just kind of coming through the top. And we're going to do the same with this one. So now what we've done is we've isolated sort of the cold from the warm. So just think of this as bad insulation, outboard substrate. In this case, bad insulation, outboard substrate, and then 2 inches of rigid foam. So the temperature right now of those decks, or drywall, is, as you can see here, it's 15.6 degrees and 17.8 degrees for the Quik-Therm, but that's going to change fairly rapidly. Now we're going to take a probe from one of our data loggers, just using the temperature here, and we're going to put this probe right beside the fastener, touching the fastener, and push it down until it just touches the deck. And we're going to do the same on this side. And push it through. So right now, the drywall or deck temperature is 13.6 degrees for the non-insulated system, and 16.7 degrees for the insulated system. The fastener temperatures, 17.1 degrees on this for the insulated system, and 16.4 degrees. Now we're just going to sit back and we're going to wait, and we're going to come back in here and just show you what happens to the temperatures of the fasteners, as well as what happens to the substrate temperature. Okay, so here we are. We're about an hour later since we set up the test. So as we can see here, the drywall temperature for the non-insulated system is 3.3 degrees. The drywall temperature for the insulated Quik-Therm system is 12.4 degrees. So we got roughly a 9-degree temperature differential between the insulated and non-insulated system. So let's look at the temperatures of the fasteners. The temperature for the non-insulated system, the fastener, is 4.4 degrees, and the temperature for the insulated system is 10.4 degrees. So it is very obvious that the rigid foam insulation is helping the fastener stay warmer than it is in the non-insulated system.